Hello and welcome everyone to another episode of the Merge AI Newsroom, our special format that we bring to you live from our San Francisco office here to talk about the latest developments in the AI world around new model releases, new frameworks, new harnesses, whatever comes out new, you learn it here from us. Today I'm super excited because I'm having Erfan here from our Applied AI team. Erfan has a great deal of experience in the AI research world. He's previously worked at companies like Stability AI. He's also built his PhD research around large language models and natural language processing. So there's really no greater person to talk to about this latest release, which we just experienced from Google coming out last week, Gemini 3.1 Pro.
Yeah, this release is really exciting, especially with the Gemini 3.1 Pro and the DeepThink and the constant progress, a march of progress towards AGI. I think they have released a lot of results on a lot of benchmarks, which are all very exciting. And we can dive in. I'm excited to dive deep into them.
There's obviously a lot of stats that we can talk about here. One of them is, for example, marking result of 77% that they achieved on these ARC-AGI-2 benchmark, ARC price verified testing. What is so special about this benchmark, and how is Google managing to get those rocket numbers?
Very, very good question. So the ARC-AGI Institute is one of the most credible institutes, in my opinion, in terms of benchmarking language models. They are a nonprofit organization. And the ARC-AGI-2 benchmark specifically focuses on general intelligence reasoning. And they don't give like texts. It's multimodal inputs and multimodal outputs. And the tasks in ARC-AGI-2 focuses on things like compositional reasoning, where you have to apply multiple rules to solve a problem and continuously adapt. They also have ARC-AGI-3, which is a slightly different task, but that's for another conversation. Models typically have plateaued up until the research labs continually push the frontier. The difference between the ARC-AGI verified badge that they released, I think, late last year or early this year, ensures the institution themselves hired a bunch of faculty that kind of advise the assessment process and oversee it from academia. And then they also collaborated with a bunch of nonprofit or a bunch of research organizations that produce language models like Google XAI and News Research. And the verified badge focuses on ensuring that the test set they use is completely hidden. It's not public. The academics oversee the evaluation themselves as well. So it's around credible results, and all the results are reproducible. Mm-hmm. They require everybody to submit their code, and the code is open source. And you cannot, you can reproduce the results.
There's different tiers that they announced, right? One of them is the Gemini 3.1 Pro API, which we can use today, and then there's also DeepThinking, which is something that they kind of teasered, right? What's the difference there?
Yeah, so I think DeepThink is the flagship model that they have. It's available through the Gemini app only on the Ultra subscription, so $200+ a month or something, whereas Pro is available at the $20 a month subscription. So the DeepThink model focuses on very difficult problems, more open-ended problems that might require good hypothesis generation, and they claim that the model is able to investigate and generate multiple hypotheses at once. Could it be this? Could this work? Could that work? And so on. And it tests them and verifies them all probably at the same time. So it can give you a more comprehensive answer, and it's very useful for solving open-ended and difficult problems. In the context of software engineering, something like fixing an issue or debugging would be particularly useful for deep thinking. Pro model is the premier reasoning model, where you give it a task and it can decompose it, plan, do the task. It's very similar to Sonnet and Opus, more so to Sonnet than Opus, I would say. Whereas deep thinking is really used for open-ended problems like mathematical proofs, advancing scientific research, and things like that. And they have a very good blog article showing some use cases of the deep think model.
Mm-hmm. Let's talk a little bit about that article, because I think one of the things that stood out to me was the amount of benchmarks and the scores that they reached on those benchmarks. And I think as like an observer who might have not done their PhD in that field, you can get a little bit confused. At least that's how I feel sometimes when I look at all these results, and it just feels like every time new model comes out, all the benchmarks are broken again. So maybe walk us through, what do these top 4 benchmarks that we see on the report actually stand for? Like, what are they built of, and why is it such a big thing this time that Google is smashing all of them, basically?
Yeah, let's start with our ARC-AGI-2, where DeepThink did almost 85% in terms of the task. That's one of the most generally impressive results that we see in this blog post. 85% was set as the grand prize for ARC-AGI beforehand, for ARC-AGI-2, and we almost are there, and that's surreal. And it's a very big difference between DeepThink and Gemini Pro, where Gemini Pro, I think I got 30%, 31%, and DeepThink got over 80%. And the best model beforehand was Opus 4.6, and I think it was at 68%. So that's a big substantial leap in terms of that task. And maybe we can see on the screen an example of the task where it's it requires really composition reasoning, symbolic reasoning, where you're looking at an image and you're trying to figure out a puzzle. Humans can do it well with adequate practice, but models really struggled with it before because it's kind of an alien language to them. You're giving them these symbolic inputs, and they have to produce a symbolic output by manipulating these symbols that they don't know what exactly they mean. They have to make sense of it as they go along. Whereas language, they've seen it a lot. They've pre-trained on it. They've seen trillions of tokens. They know how to manipulate language. They know how to write, but they cannot manipulate symbols that they don't know what it means. This is a true hallmark of intelligence testing, where we're benchmarking models on tasks they've not seen before. And how we got there, I think I could come up with several hypotheses. Probably models were trained on alien symbolic reasoning languages or tasks that require symbolic reasoning, where they're given a bunch of symbols they've never been exposed to before, and they have to manipulate them to solve a puzzle. That might have been part of their post-training, but this is all speculation. I don't work at Google, so.
Yeah, of course.
Yeah, that's the first benchmark. And then we can talk about Humanities Last Exam and Codeforces particularly, because also these 2 benchmarks are very impressive and more related to software engineering. Humanities Last Exam, I think 40% of the questions are mathematical related. Some of them are computer science and AI related. And so all of the answers can be verified automatically, but they're very, very difficult questions. All models almost plateau at 40%. And it's very difficult to cheat on them because retrieval doesn't help with solving them. It requires raw reasoning. And Codeforces is a platform where you can submit your code solutions, programming solutions. It's very similar to LeetCode, where you have a task specification, inputs and outputs, and you have to write a program in a specific language that solves it. And it's compared to against everybody else who programs on the platform, so humans and machines. And it's a ELO ranked system. So it's similar to chess, where it's a rank compared to everybody else who programs. So this substantial leap in improvement means that models that are really good at hypothesis generation and coding are really becoming really good compared to humans on LeetCode programming. This is genuinely impressive.
Maybe let's take a little step back and think about, okay, what does that actually mean for developers? Can you translate somehow what all these impressive results on these massive benchmarks will ultimately yield to for people like you and me who are trying to implement a task with one of those models, or especially with Gemini maybe?
I think Gemini is becoming really good at solving workflows. So I think they also scored really high on Terminal Bench. So giving it traditional toolings like CLI, it can perform tasks well, and models keep getting better at performing end tasks well, so long as the task is well defined and you know what you want to solve. And I think what that means for developers is, I think design becomes more important than conceptualizing the task and defining the task well. In other words, prompting becomes really, really important as opposed to solving the problem itself or doing the task by hand. And the Codeforces performance tells us that I think traditional leak coding and implementing traditional algorithms and pattern matching problems to algorithms becomes less important because AI can do that well. And what that means for us is it becomes more important to define problems as opposed to solving them when it comes to programming, I think.
There's also the more, let's say, practical viewpoint. For example, we saw on Terminal Bench 2.0, for example, that there are different scores for the agentic terminal competency versus things like, tools, no tools, search and code, all these other different, more elaborate testing methods that we have where we see how models perform in practical agentic applications. Can you speak a little bit to that?
I think SWE-Bench verified, there are quite a bit of SWE-related tests that they've benchmarked against. I think the SWE-Bench verified is probably the most relevant. This basically is real-world repositories that are scraped off of GitHub, and then you have to resolve real-world issues and real-world bugs, and do a PR. It's a complete end-to-end, and the model can just go in, clone the repository, perform tasks on it, edit the code, test, and then submit their PR when they're ready. However, the task is well defined, so you have an issue that describes a bug or something that needs to be done in the repository, and the agent has to go in and implement it and verify that the implementation works. Mm-hmm. So this is substantial improvement to where we were like a year and a half ago when the SWE-Bench was just released and models were struggling to do this task.
Yeah.
But now we have the infrastructure in terms of agentic coding, in terms of terminal, in terms of cloud code, in terms of like cloning repositories, verification, running commands in grep, so running commands in the terminal, running verification, writing unit tests, and so on. And also retrieving code documentation. That was a huge thing.
Yeah.
That all really enabled this rapid progress, along with raw intelligence advancement of the models themselves and them becoming more capable.
We also run some benchmarks here at CodeRabbit internally, right? So how did Gemini 3.1 Pro perform on those benchmarks compared to other models like Codex or Opus?
Yeah, so generally Gemini, we have preliminary results, so we're still running more evaluations as we speak since the model just came out. Generally, Gemini Pro produces less comments than the other models what we currently have. And then I think it's about by 24% less comments. And it really tries to focus on comments that are critical. We observe relatively similar performance in terms of whether it catches the issue that we intend the model to catch, like the core issue behind the PR or the core issue behind the bug that we're trying to find. And then it doesn't really write nitpicky comments as much. It tries to avoid that. So things that, maybe the developer intended, like an issue, like a logger using info instead of warn or something like that. Like small comments that the developer might be aware of or might not, but it's not really important to address. Gemini doesn't seem to highlight that at all, which might be useful for some developers and institutions, but maybe not for everybody. Another thing I would highlight is Gemini Pro is cheaper than the other frontier models, cost per token. And I think, how many tokens it produces, that depends on the workflow and the implementation of the reviewer systems. But that's something that I think people should be aware of as well. But generally, it's good bang for buck. It produces good value compared to the cost, compared to the other frontier models, just because it's cheaper. And if you get comparable performance, that's useful. One interesting finding that we had while doing our internal evaluations is that when the Gemini comment captures the issue we intend, like we are looking for, the core issue, it tends to be a little longer and assertive in its claims. So it uses less hedging language, might, should, not, maybe.
Yeah. It seems to be like a general trend. I had David, our VP of AI, on here, I think 2 weeks ago when the GPT Codex 5.3 and Opus 4.6 dropped. And he was also noticeably mentioning this trend of models becoming more assertive and more sure of themselves, so to say. Is that something that you see as well?
Yes, it's becoming more assertive. And there seems to be a correlation between the comments that highlight the issue that we intend, like if it captures the issue we want it to, it tends to be more assertive than the comments where it doesn't. So there's that. There's some correlative relationship here between assertiveness and whether it captures the intended ground truth behind the core issue.
Interesting. Yeah. There's also another new thing that Gemini 3.1 Pro introduced, which is this custom tool endpoints that where you can set certain thinking controls. So for people building agents, there seems to be, is there a practical difference between like setting a smarter model to think longer, shorter, and what difference does that make?
Yeah, the most obvious trade-off here is cost. So the less thinking it does, the cheaper it is. Pro is generally really good at a lot of things, as you can see from the benchmarks. Generally, simple tasks that you might use Flash, you could use Flash for, Gemini Flash, I mean, and or like it doesn't require a lot of reasoning, like question answering maybe. Like you could use low thinking, and by default you could use the medium thinking. And for more complex problems that require more thinking and more analysis, multiple tool calls, potentially, you would want to use higher thinking.
Talking about the context window size, right? I think Gemini, we talked about this, has always been a model that has a lot of input token window length. Where do you see the benefits? When should when should somebody default to using all that context, or when should somebody maybe think about better, clever context engineering techniques in order to get the most? And where do you see the cost benefit here?
I would say generally, as a rule of thumb, if retrieval can solve the problem or a subset of the problem, you should use it. Retrieval is a very powerful tool, so long as the model remembers and knows how to retrieve. And most models now are trained agentically, so they can use tool calls very, very well whenever they need to look something up. I would say passing really, really long files to a model, so like having a long document or a long message, tends to produce this phenomenon of context rot more often than longer conversations. I would try to break things up. Like a really big code file should be broken up into smaller chunks, maybe send it by function or maybe line by line, as opposed or a subset of lines, that are relevant for what the model is trying to do, as opposed to feeding in the entire file all at once. But generally, models do really well. We're talking about millions of tokens here. The context window is 1 million, so it does really well. But feeding it a really big JSON file of 100 million lines probably wouldn't be a good idea when you can just grab things.
So, we talked about just before as well about this previous paper, Needle in the Haystack, right?
Yes.
How do you see that evolving? I think this paper is now 2 years old. It's quite some time in AI age. That's almost ancient. So, how did you see the model development evolve on that? Is it now, are the models better at finding the needle in the haystack, or do we still experience similar problems? So
I wouldn't say the problem of context rot is solved, but I don't think it's as important because we have infrastructure to retrieve things. So instead of feeding the entire 100 million line JSON file to a model can just write a grep statement to look for what it needs from that JSON file and answer or perform the task to respond well. So I think that perhaps it's a less relevant problem because we have digital infrastructure that models can use to answer them. But that's my opinion.
Yeah.
Maybe people would disagree. Also, it's more expensive to feed in very long inputs to a model. So in terms of cost efficiency and maximizing value, I think it's very useful to build infrastructure for models in such a way that you can optimize cost and performance. And retrieval is such a very good tool for this. And models are really good at using them.
So, I guess that fits our narrative. Context engineering is still king.
Yes.
That's right. Let's talk about the token economics. You already touched a little bit on, Gemini being more cost effective. Can you elaborate a bit more on what should builders be looking for? When does it make sense?
The Gemini models typically are a bit cheaper than the other frontier models. Google tends to price them a little better, probably because they have good cloud infrastructure. Generally, the Gemini models do as well as the other frontier. They keep up. They're not behind. And I think it's a cat and mouse game where somebody releases a new model and it's slightly better than the other models at certain things, but mostly they're neck to neck. So it's wise for institutions and companies and builders to be able to adapt and quickly evaluate all of these frontier models quickly on their use cases or in their domains and see what works best for them. The best is unclear, and it will continuously be unclear for the foreseeable future in terms of models. And there are trade-offs like, how much do I want to spend? And which model is cheaper? Do I want to maximize performance or cut costs on this specific subtask? Having the infrastructure to run evaluations quickly, concisely, and extract insights on I should use this model here, I should use this model there, maybe I could use a cheaper model here, I think would be very useful for institutions.
You already touched on the outlook a little bit here, which is great. What should we be excited about for developers, especially maybe looking at Google and the models that they'll be releasing soon? Is there anything that you're waiting on?
I would love to try DeepThink.
Yeah. Why?
It seems like it can explore multiple ideas at the same time, generate many hypotheses. It's very useful for scientific research. It's very useful for open-ended problems like mathematical proofs. It won the Mathematical Olympiad, the gold medal in Mathematical Olympiad like a year ago and more recently. And it's very good at, I really want to use it for debugging and see how it does there. I think if they release an API for that, that would be fantastic. You can experiment with that. And I think another thing that I'm looking forward to from Google perhaps is like if they do any integrations with their anti-gravity IDE. They released an anti-gravity IDE last year, which seems to be really good for prototyping UI specifically, and generally it's an agentic IDE. And I think that, DeepThink there could be very cool.
Yeah, game changer. Wow. Yeah. Okay. Well, thank you. There you heard it, folks. So keep an eye out for that. Thank you so much, Erfan, for taking the time and talking to us. We'll have you on here again, I'm sure.
Yes.
So thanks for joining in for the show, and talk to you guys soon.
Thank you for having me.